Hello everyone, welcome back to my channel, and in this video we are going to discuss important questions for module 4. So the thing is, what happened is when I recorded the video, and by the end of the video what happened is I couldn't, my laptop stopped working, and it didn't even auto saved, and I was totally blank. So whatever 45 minutes video it was, it just vanished. Okay, so I was so upset about it, and again I'm re-recording this video for module 4. It's okay, that's what happens in the life, so nothing to worry about it. So yeah, I'm just re-recording this video for module 4. It was recorded, but I couldn't save it. It just vanished. I don't know what happened to my system. But yeah, so coming back to the video, in this lecture, we are just going to cover the important questions for module 4. So here you're going to have two part. One is decision tree learning and second is Bayesian learning. Okay, in tree learning, introduction to decision tree learning model, decision tree induction algorithm you are going to have, as well as in that you are going to have the formulas where numerical also they can ask, and also the theory based question. And then you have a concept called validating decision tree, and then pruning of decision trees. Okay. And next in the part B, you have Bayesian learning, introduction to probability based learning, fundamentals of bias theorem, classification using bias model, and next is Naïve Bayes for continuous attributes. So here in this also one numerical is possible. Okay, and in the OR question, they can ask you numericals related to Naïve Bayes for continuous attributes. Okay, so problem numericals from this concept and also from decision tree learning concept you're going to get. Okay, so next slide is about expected PYQs for module 4. So here you can see I have distinguished for the concept called decision tree. What are the possible questions? If you read these questions for the theory part, definitely you can score. Let's assume that if they are not asking any numerical questions, so if you know these theory questions, you are definitely going to score out of for module 4, which is 20 marks. Okay, so approximately, even if you write everything, let's say we can take 17 to 18 marks, 1 or 2 marks, even if they deduct, here definitely you can score good marks. Okay, but I would suggest you that do not skip the problem for decision tree. It is very easy. The only thing is, sorry, only thing is you should remember the formula and the steps to calculate the entropy, and then information gain, and followed by the Gini index. Okay, similarly for Naïve Bayes, you should remember the formula, what are the steps, how you are going to calculate the probability, okay, for the given date, okay, using the probability formulas. Okay, so these are the possible questions. So read this 11 questions. Okay, and next slide you can see for one first question. So here I'm going to start, and whoever are reading for the last moment, if they are getting confused from where to start, what to read, even if they go through this question and whatever answers I have mentioned in the slides, you can just read out these points and try to remember these points and just write down these points in your exam. Okay, so not only for this modules, in the previous videos you can refer for module 3, module 2 and module 1. Whatever keywords I have used over there, you can just remember those keywords and write down in your exam. And for detailed notes, you can refer in my website called vtusmartprep.com. Okay, so it is still in the initial state, but still I'm managing my personal time and I'm trying to upload the notes over there. So, and also I'm spending some time to make videos for important questions, and here I'm not covering the explanation part, but just mentioning the important questions, and for this specific question what all key points are required, that I'm just covering in the video. Okay, so I hope this is very last minute preparation. So the only thing you have to remember in your mind is you have to study. Okay, don't get distracted. You just try to understand the keyword and remember the key points. Okay, so remember that in your hand you have, what you have in your hand is to study and pass the exam. Okay, you don't know what the question paper is, whether it is going to be difficult or easy. That is not there in your hand. But in your hand, what you have is you can study, you have to study. Okay, that is the part is there in your hand to do, right? So think about that. Okay, that is how you have to make your mind think. Okay, and try to study. Okay, next is, this was about first question, explain decision tree learning model. So explain what is decision tree. And in decision tree you're going to have the root node, and then followed by the branches. Once you have the branches, you're going to have the leaf nodes. So those leaf nodes is going to categorize whether which class it belongs to, whether it belongs to S class or no class, is what in general decision tree model tells us. Okay, so where it is going to, okay, so leaf node is going to predict whether the data belongs to class 1 or class 2. So class 1 is the S class, and class 2 is the no class. Okay, so in decision tree, you're going to have the root node followed by the branches and the leaf nodes. And at the leaf nodes, you're going to find whether the data belongs to yes class or to the no class. Okay. Next is decision tree induction algorithm. So you should know the steps for induction tree, decision tree induction algorithm. So here it is, in the first step, it is going to check all the samples belong to the same class or not. Okay, once it checks, okay, whether the sample belongs to class or not, if yes, it is going to create the leaf node. Okay, if the sample belongs to the same class, it is going to create the leaf node. If not, what is going to happen, it is going to check the attribute. Okay, and wherever has the highest majority, okay, there, okay, in that class it is going to add the leaf class. Okay, it is going to create the majority class leaf. Okay, and once, okay, so and how it is going to find the best attribute, okay, majority class, how it is going to find, it is going to find using the split criteria. Okay, in that split criteria, these things you have to remember. Okay, so what I said, first step, the sample is going to check whether which class it belongs to. Okay, if it belongs to the same class, it is going to create the leaf node, and if not, it is going to create a attribute, okay, which has the majority class leaf. Okay, and how it is going to find the majority best attribute class, it using the split criteria. Okay, so in split criteria you have to remember this. Okay, in split criteria it is going to use the information gate, it is going to use the gain ratio, and also it is going to use the Gini index. These three things you have to remember. Okay, so using split criteria, in split criteria you're going to have the information gain, gain ratio, and Gini index. Okay, and then create the branch for each attribute value, and then recursively build subtree for each partition. So it is going to reward. Do you mean by recursively? It means that it is going to repeat the same steps again and again. That is what recursion means, right? So recursively, it is going to build the subtree for the each partition. Okay, so these are the steps for decision tree induction algorithm. So this was the second question. So it will take time to explain questions. Here I will just tell you what are the possible questions, and in PPT here you can see the points which you have to remember. What all things are required, important things required to mention for the specific concept. Okay, so you can, third question is entropy. Okay, they can say explain entropy, information gain and gain index. At that time mention the formulas, okay, and what entropy means, okay, what it is going to calculate, that you have to mention. Similarly for gain, information gain, what it is going to measure, what it is going to calculate. Okay, for the decision tree, those things you have to mention. Similarly for gain index, okay, what it is going to do and what it is going to calculate is what you have to mention on the theory based questions. For this thing only you are going to get the numerical. Okay, they are going to give you the data set, so according to the data set you have to calculate the entropy, information gain and gain index. Okay, so I'll just cover the questions, important question. And for this, you just refer the detailed notes from vtusmartbread.com, or else you can just refer the slides to remember the points. Okay. And problems you have to solve. Okay, if possible, I'll try to make video on solving the problems. Okay, but before that, I'll complete the series. Okay, module 5 questions also I'll share it, okay, on the YouTube channel. And then if I get time, I'll try to make a video, okay, one small video for decision tree problem, and as well as for information, no, decision tree, and as well as for Navy bias problems. Okay, so fourth question is decision tree numerical, that is what I was talking about. So here also you will get the problem, that is what possible question is there for decision tree numerical. Okay, steps to solve it. Okay, here I have not taken any example, but these are the steps to solve the decision tree numerical. Okay, so with an example, if possible, I'll try after this, I'll try to make the video with example how to solve the problem for decision tree. Okay, so next question is, okay, here I'm just covering the theory part questions, which are the possible questions. Okay, and very easy, do not skip the module for easily theory questions is understandable. Okay, you will be easily understandable. If you understand the concept, very easy to remember the answer and write the answers, right? So that is why I'm telling you, do not skip this unit, okay, for the exam. Next is validating decision tree. So here you have to explain what is validating decision tree. So a decision tree may fit training data very well, but perform poorly on unseen data. Okay. So validation estimates generalization performance and detects the overfitting. So in general, I can just explain you how you can remember. Validating decision tree is nothing but in decision tree, it is going to perform or train the data very well. Okay, okay, very well on the known data. Okay, so you have the data and it is training the data using some model, machine learning model, and it is training very well, but on known data. Okay, what if there is some unknown data? Okay, so in unknown data, it is not going to train it properly. Okay, it is going to train very, you see, or you can see it is going to perform very poorly on unseen data. Okay, for unknown data, it is not going to perform well. Okay, it is not going to perform well. So there is the problem. Okay, there is the problem where it is called as overfitting. Okay, when the data is not training well on unseen data, so it creates a problem, right? At that time, what technique is being used? Validation. Okay, so validation estimates the generalization process and it detects the overfitting. Okay, so it is going to avoid that problem, and then it is going to make use of validation technique for the unseen data. Okay, so as simple as that, I just made you understand the concept called validating. Okay, so when what is the need of validation? Okay, so it creates problem when you have unknown data. Okay, and the machine learning model perform very poorly. So at that time, validation takes place to estimate the generalization process performance, and it detects the overfitting. Okay, and it is going to avoid that problem, overfitting problem. Okay, so what are the common methods which a validating technique uses? hold holdout validation, train test split, K-fold cross validation, validation set purine, accuracy comparison before and after purine. So these are the common methods used in validating decision tree. Okay, and then outcome validation helps choose the tree that is accurate but not too complex. Okay, validation makes sure that it choose the simpler but not too complex. Okay, and a validated tree should perform well on new examples or the new data, not only on training exam. Okay, so validation should perform well on the new datas, okay, or new samples, not only on the known samples. Okay, so this is the fifth question on validating decision tree. Next is pruning of decision trees. So they can say explain purring of decision tree, then you have to explain purring meaning. Okay, it is going to remove the branches that are caused by noisy or very small patterns in training data. It reduces the overfitting and improves the generalization. So here also you have two types. One is pre-pruning and second is the post-pruning. Okay, so pre-pruning is going to stop growing the tree, okay, at the early stage, and post-pruning, what it is going, it will grow the tree fully and then remove the weak branches. Okay, these points you can remember. Okay, and along with diagram, you can just explain this answer. Okay, very last minute preparation. Okay, I'm not making it very confusing. Whatever simple things I'm able to explain, I'm just trying to make you explain. Okay. So next is advantages and limitations on decision tree. So explain the advantages and limitations. Okay, limitation, they can say advantages and disadvantages. Okay, disadvantages are nothing but the limitations. Okay, so this is the expected question. Eighth is introduction to probability based learning. So this is related to bias in learning, where you have bias in learning and Naïve Bayes. So here you have to remember these key points. One is prior probability. What is prior probability? You should know. Next is likelihood. Okay, these terms you should know. What is likelihood formula? What is prior probability? Then evidence, posterior probability, and maximum of posterior decision. At the end, you are going to know in the result or in the output, you're going to find which is the maximum posterior decision. So these keywords you should know. Okay, how you're going to write the prior probability, how you're going to write the likelihood, how you're going to write the evidence, and how you're going to write the posterior probability. Once these steps are done, you are going to get the maximum posterior decision. Okay, you have to find the maximum posterior decision. Okay, so it works well when a data is uncertain, noisy, or incomplete. It provides a mathematical stronger way to update a belief after observing the evidence. Okay, so that is useful. Okay, when you use the probability based learning or Bayesian learning techniques. Okay, so we'll see the questions for that. The state and explain bias theorem. So you have formula and then you have to explain what P of H by E means. Okay, P of H, what it indicates. Okay, so you have to explain each terms. Okay, so just now in previous slide I told you, right, you should understand what prior probability is. So this is how it indicates prior probability. Then I said you have to remember what likelihood. So this is how it is represented, likely. Okay, so similarly for evidence, and then in the end you're going to see here after formula you will be able to find the posterior probability after evidence is observed. So formula you remember, and watch what each term represent is what you have to write. Yeah. So moving to next question is classification using bias model. So same thing. So here you can have the formula and these are the steps followed for the classification using the bias model. Okay, this is the algorithm for the bias model. Okay, so it is going to train this as data or the samples, then estimate the P of class, and then it is going to estimate the P of feature class. Okay, and then it applies the bias theorem using a formula, mathematical formula, and then it is going to choose the max posterior. Okay, so these are the algorithm steps which you can remember to write for the theory question. Okay, they can ask you theory. Okay, explain the classification of using bias model. So these steps you have to write in the sentence. First, in the initial step, it is going to train the sample data. Okay, given sample data, and then it is going to estimate the P class. And the third step, it is going to estimate the feature or class, and then okay, then apply the bias theorem, and then it is going to choose the max posterior. Okay, so and next, how it is going to do the prediction rule? There is a formula. Okay, classify x into class of c star. Okay, c raised to the star, where p of cx is maximum. Okay, so this is the prediction rule which you have to remember for the classification. Okay, how it is going to classify using this prediction rule, it is going to classify, right? So this is how you have to write the steps and formula. Okay, next is Naïve Bayes. Similarly, here you are having the formula followed by the step of the algorithm, how it is going to predict the max score. Okay, or how it is going to predict the max posterior. Okay, so here these are the steps for which Naïve Bayes. Okay, and this is the formula for the Naïve Bayes classifier. Okay, so this is the 11th question. So here in Naïve Bayes also they can give you the numerical problem. So with an example you have to solve it. So here you can see the algorithm steps which you can remember. Okay, so they can say write the algorithm, Naïve Bayes algorithm for training phase as well as testing phase, or they can directly say explain Naïve Bayes algorithms. So both the phases you have to explain. First one is for training phase, these are the steps, and for testing phase, these are the steps. Okay, and for training phase it is denoted as T, and for testing phase it is denoted as P. Okay, so this is how you can explain or remember the points for Naïve Bayes algorithm steps. Okay, and next is, yeah, in Naïve Bayes, this is for continuous attributes. For continuous attribute, this is the formula. These are the steps. Okay, and this is theory question. So write the formula, mention the formula. Okay, then mention the steps, and then followed by this graph diagram. Okay, so this is the pattern to explain the theory concept for the Naïve Bayes for continuous attributes. Okay, so here also you can expect the problem. So again, here you can see phase by phase how steps are being used to calculate the numerical problem for Naïve Bayes continuous attributes. Okay, these are the steps to solve the problem, numerical problem for Naïve Bayes of continuous attributes. Okay, possible questions. This is the 14th question where you can have the numerical question for continuous Naïve Bayes. Okay, or you can say Naïve Bayes of continuous attribute. Okay. And last is compare the decision tree and Naïve Bayes. Okay. So decision tree and Naïve Bayes comparison they can ask for 5 or 10 marks. Okay, or maybe 8 marks. So yeah, this is the last question. So here 2 marks question possibilities, 5 marks question possibilities. But yeah, whatever in previous slide I have mentioned, those concepts you keep on reading. Okay. And give most priority to these theory questions. Okay, for 10 marks and 5 marks. Okay, these also you read, you should understand. Okay, because in question, no, if it is for 10 marks, they will say what is entropy, and then they will tell you explain the validation method, or they can also add the question like write decision tree induction step. What is entropy, and write the decision tree induction step. So in one question only 2 sub questions can be there. Okay, so they will divide the marks like this for 2 marks and the rest of the things for 8 marks. Okay, that is how. So give the priority to all these questions and read it thoroughly. Okay, and spend 2 hours or 1.5 for each unit, and definitely you will be able to study. Okay, if you concentrate, you will be able to study. Okay, so this is a formula sheet which you can remember. Okay, to write in the exam. So yeah. So last minute preparation, how you can do. First 30 minutes revision should be decision tree. Okay, and then root node, leaf node diagram, induction algorithm, entropy, and then information. This is easy. Also revise for Bayes theorem, Naïve Bayes derivation, Gaussian formula, and one numerical problem for this. One numerical problem for Naïve Bayes and one numerical problem on decision tree. Okay, where you are going to calculate the entropy, information gain, gain index. Okay, so that's it for this video. And if you want the notes, okay, it is available on vtusmartprep.com. You can visit the website, sign up. Once you get the confirmation mail, you can just sign in, and you can select the department, and you know you select the semester, and there you will be able to find the notes for this subject. Okay, so that's it for this video. And if you want important questions for module 5, you can just comment down on this video. And sorry for the delay, so due to some issues I couldn't upload it, but yeah, I'm trying my best, okay, to spend and take out my time to make videos and upload. Okay, and I will make sure that for the upcoming subject I will explain the concept, okay, followed by question and then followed by answer, is what I'm going to try to do for the rest of the subject. So let's hope for the best. Okay, but yeah, the only thing you can do is study well. All the best. Okay, study till module 4, and also I'll try to share the important questions for module 4. And for now, bye bye, take care, and see you in the next video.